Assertion reason. Statement 1. If air resistance is considerable, then the time of ascent and time of descent will be different. Statement 2. Magnitudes of acceleration will be different in upward and downward motion. Now we want to check whether statement 1 and statement 2 are true and statement 2 is the correct explanation of statement 1. B part, statement 1 and 2 are true. Statement 2 is not the correct explanation of statement 1. C part, statement 1 is true, but statement 2 is false. And last one, statement 1 is false, statement 2 is true. So let us see one by one the two statements and check whether first statement and second statement are true individually. Then we will relate these two equations or these two sentences and check whether statement 2 is the explanation of statement 1. If air resistance is considered, then time of ascent, time of descent will be different. So let us see how to take time of ascent and time of descent. When we are talking about time of ascent, that means the motion of the body is in the upward direction. Suppose if I take this body moving in the upward direction, this body is projected from the ground. So this body is moving in the upward direction. So the mg force will be acting on this body. The motion of the body is in the upward direction. Now mg force is acting in the downward direction. Also the force of resistance, that is I am talking about air resistance, that is also acting in the downward direction. This is air resistance. So the net force will be equal to mg plus the force of resistance. If air resistance is not taken into account, then we can write m into a is equal to mg and a is equal to g. Plus now we have to take the force of resistance. So the net acceleration in the downward direction will be more. So this is a retardation which is there existing on the body. We'll put a minus sign here. So A is equal to minus G plus F resistance given by the air divided by N. This is the retardation. So if you project this body with a certain velocity u, the retardation will be more. So the body will be moving here. Time of the ascent will go on decreasing. If the same situation we take it for the motion of body in downward direction. Now the motion of the body is in the downward direction. Then what are the forces which are acting on this body? Weight will be acting in this direction again, mg. The force of air resistance will be in the upward direction because the body is moving downward. So this is the air resistance. So here F dash will be equal to mg minus this force of resistance, or m into a will be equal to mg minus force of resistance. So the acceleration will be g minus f by resistance divided by m. So the acceleration in the downward direction decreases. So it will take more time to strike the ground. So time of ascent and time of descent will be different. So first conclusion we get that time of ascent is not equal to time of descent. So if you look into the first option, statement 1, if air resistance is considerable, then time of ascent and time of descent will be different. So this is true. The first statement is true. Let us see the second statement. Magnitude of acceleration will be different in upward and downward motion. This is also true statement. See, magnitude of acceleration is different magnitude because the directions are different here. Here g plus f resistance by m, here g minus f resistance by m. So second statement is also true. And since acceleration is different, time of ascent is time of descent is not equal. So the second statement is the correct explanation of the first statement. So option A is correct. Option B definitely will be wrong. And first statement is second is false. This is also wrong. First statement is true. Second statement is false. Option wrong. First statement is false. Statement 2 is true. This option is also wrong. So here also the correct answer will be in this problem as option A. So answer will be option A.